Hello, welcome to the study lab. In this video, we are going to be introducing limiting reactants. So I can definitely post future videos with more complex limiting reactant problems, including molarity and all sorts of problems. But here we're just going to look at it a little simply with a basic real world example and then a simple chemistry problem. So let's start with a definition. So what is a limiting reactant? So a limiting reactant is a substance that is consumed first in a reaction. And if you think about that definition, it really determines the longevity of a reaction, right? Because let's say there's two reactants. Once one of them is used up, even if the other one is in excess, the product cannot be made without both of them. So if one of them runs out, that's it. The reaction is over at that point. So the reactant that prevents more product from being made, that is the limiting reactant. So let's look at this concept in a simple real life example. So here we have an example with 5 pots and 7 spoons, okay? To make rice, you need 1 pot and 1 spoon. So let's look at this in a chemical sort of view. So the number one step, I have my steps for limiting reactants here. Balance the chemical equation, right? So here, it's not necessary, it's not a question, so we're going to skip that. It's a simple example right now. We're going to go to step number 2. Convert given to moles. Let's look at what we have. Well, this isn't very relevant right now, so we can ignore that step. We can look at it in the next problem. Calculate how much product each reactant makes, okay? So let's see. This right here, our pots and our spoons, these are our reactants. So let's see how much product they both make, okay? So we're given 5 pots, and this is another very important concept you need to know. This will help you solve every limiting reactant problem, and that is to list your reactant, right? And make a mole to mole ratio type thing, okay, right here, as we did right over here, with the thing that we're trying to get to on the top and the thing that we want to use on the bottom. So we want to cancel out the pots and the pots because we want the rice. We want to see, okay, how much product does it make? This will help you in every problem. Try to cancel out the thing that we don't need. Okay, so here we can cancel out our pots and our pots. So let's just do that, because 2 things on top of each other are equivalent to 1. So this is on top, the pot's over here is on top, and the pot down here is on the bottom, so they cancel out. Yes, we're left with our rice. So let's see. We make 5 rice dishes from the 5 pots. Now let's do this exact same process for the spoons. 7 spoons. 1 rice dish requires 1 spoon, as evident over here, right? Now, we can cancel our spoons out. Hooray, this is the best point where you can cancel the stuff out. You need to do it. And we're left with our rice. That's perfect, that's what we're looking for, right? And we're left with, okay, that's interesting. We get 7 rice from this. This is an incredibly important step. You cross out the larger amount of product that is produced, because what did we say earlier? The limiting reactant determines the longevity of a reaction, and it produces the least amount of product, so we can instantly just cross it out, don't even think more about it. What are we left with? We're left with our 5 rice. So what is the limiting reactant? It's the pots. The pots are the limiting reactant, okay? Because the pots run out first. If we had 2 more pots, we could have made more rice, right? So it's the reason that we can't make more product. So this is our real life example. Now let's go to a chemistry example. And as I mentioned, these steps are going to be more relevant in the chemistry problems. And especially this step right here, convert given to moles. Given to moles. Everything you want in moles. That is what you need for every chemistry problem regarding limiting reactants. Let's look at it. Here we have a question. Determine the amount of water formed. What is water? That is our product. What is water? It's our product. How much of it do we get? When with the two reactants we are given. Let's look at this first equation. So first off, I want you to notice that, okay, we're already given the balanced equation. Let's go straight into our problem. We're given 6 moles of H2. Okay, look at that. This is our reactant. Okay. And 4 moles of O2. That's another reactant. And we want to determine the amount of water formed. So as we did earlier, let's first just go slowly. List our reactants, one on top of each other, and determine the amount of product formed from both of them. Now, to get our water, what did we say? The thing that we want to get to goes on the top. The thing that you want to get to. The thing that you're using to get to that thing goes on the bottom. And also because we want to cancel it out, right? So let's see. 6 moles of H2, okay, that's our reactant, and that's what we're given. And we're going to use our mole to mole ratio to determine how much the 6 moles of H2 makes, okay? Now, 6 moles H2. Oh, look, we use our mole to mole ratio by looking at the balanced equation. So let's look at the balanced equation. 2 moles of H2O. Let's look here. Oh, 2 moles of H2O. How much H2O? 2 moles of H2O. How much H2? Let's look back here. 2 moles of H2. So we plug that into our mole to mole ratio. Now look at that. We can easily cancel our moles of H2 out, and we can determine how much product H2O is made. 6 moles H2O. Now we repeat this process. Remember, look at our balanced equation for this portion, the mole to mole ratio. And we can cancel our moles O2, and we're left with moles of H2O. That's what we're looking for. See, now that we have moles of H2O for both of them, now we can compare them. What did we do next? What was our next step? Oh, right. The reactant that makes the lower product is the limiting reactant. Compare the amount of product formed. And the bigger one, you instantly cross it out. What's our limiting reactant? It's the H2. That's another point. You don't say, oh, H2O is the limiting reactant, because it might look like that, right? Because we're looking here. But H2 is the reactant that produced that much H2O. So this is the limiting reactant. H2 is the limiting reactant. So that is the end. This is a introduction to limiting reactants. I hope this was helpful. For future videos, I can add more complex problems, okay, what if we are given grams, as I mentioned here? We convert it to moles, and then we do the exact same procedure as we did here. What if we need to balance the equation? Well, you do that first, and then you do your grams to moles, and then further steps. So, yeah, I hope this was a good introduction, and good luck in chemistry.